All right, this is where we're actually going to start the pre-calc stuff. All right, I told you second half of the year, some pre-calculus topics. This is where it actually starts. What have we been doing the whole time so far? We've been doing some Algebra 1 review and some Algebra 2 review. Now we're going to get into the pre-calc stuff. Do not get freaked out. It's not that bad. I am still going to ask you guys to graph lines into shade for me. That's not going to change. So some of you guys I got to work on a lot, all right, because we still need to improve on graphing our lines and shading them. New vocabulary right off the bat. Every problem we do for the rest of the unit, you're going to see this right here, which is called an objective function. What it is we're going to plug in numbers for x and y and see which pairs of x and y give us the highest and give us the lowest values for z. So that's what that is used for. We are not going to graph it at all. We are just going to plug in values of x and y to see which pairs of x and y give us the highest and lowest value for z. So you guys can see over to the right, what I did before you came in was, hey, I did my lines and my shading. And this right here, this figure, is where the shaded region overlapped for me. So all my shaded region overlapped in this figure right here. A five-sided figure. And I took the points of those five-sided figure. And what I need your help with right now is taking those points, plugging it into my objective function, and seeing which pair gives me the maximum value and which pair gives me the minimum. So for example, 3, 2 is a point in that shaded region there, a point on the outside, 3, 2. So I'm going to take 3, 2, and I'm going to plug 3 in for x, 2 in for y into the objective function and see what I get out for z. So I'm going to say z equals 3 times my x value, 3, plus 2 times my y value, 2. And I'm just going to find out what that's equal to. And then we end up with 14. Okay, so that gives us 14 when I plug in 3 and 2. All right, we got more points to plug in. Next one I see is 410. So now I'm going to plug in 410 instead and see what value I get for z.
Mr. Carlino?
Yep.
Wasn't z 13, not 14?
God, I did it. And you are correct. And you know something? Why I'm so fired up about that? Not that I just got that incorrect. This is the second time I got that darn thing incorrect. I put 9 in my second period class. Oh my God. Are you kidding me? And they let me teach. Thanks, Anna. 3 times 4 here. Plus 2, now plug in 10 for y. Now I'm going to be rattled the whole dang class. Watch my language. Let's see if I can do this one right. I got 12 plus 22, or 20, almost did it there. 12 and 20. 32 for that one. All right, go ahead. You got 3 more points now to test. 3 more points. I got to figure out which pair. It says which pair will give me the max value and what's going to give me the minimum value. So go ahead. Now 8, 6, 7, 4, and 5, 12. Sorry, I went out of order. And then I'm going to go back to calling on you guys here. All right, hopefully I gave you enough time. If not, keep working. Here we go. Give me the z values for all three of those points. Here we go. Liz, you're up first. Liz, what do you got? 8, 6. What'd you get for the z value?
36.
Good work. How about 7, 4, Liz?
29.
Yes, yep. And 5, 12.
39.
39. Thanks, Liz. Appreciate it. All right, let's answer the question now. What's the maximum value of this objective function? What's my max value? So look at all our z values. What's the max value up here? Here we go. Will, what's the max value that I ended up with?
39.
39. Max equals 39. Stay with me there, Will, because it also asks what's the minimum value of the objective region. What's the minimum value, Will?
13.
13. There you go, guys. $39 and 13. And today, all I'm going to have you do is find those. Later on, we're actually going to set it up, do a word problem, and know what the max and min actually mean. Questions there, finding our max and min using the objective function. All right, now all I'm going to ask you to do is, you got to find the shaded region now. I did it all. I did the hard work for you in number 1. Now I want you to help me out in number 2. All right, before I should have deleted these. All right. Here's what I need you to start getting in the habit of. Before you set up your XY axes, because not all the time is it going to be first quadrant anymore. I need you guys to find all your intercepts first. All right. Find all your intercepts first, and then we'll determine on how to make the graph. Do we need 4 quadrants? Do we just need the first quadrant if it's all positive? So let's start getting in the habit of finding all the intercepts first before we start constructing the graph. All right, so we got to graph all these to find our shaded region first. So there's our objective function. We're not going to graph it. When we're ready at the end, we'll plug in x and y. All right, so the first 2 are 0 and 0, so those are positive. So those are right on the corner, so I don't need to worry about those. Here you go. 2x plus y less than or equal to 8. Find your x-intercept. Find your y-intercept. Some of you guys are still struggling with this. It's a diagonal line. It's going to be a diagonal line, not horizontal or vertical. Plug in 0 for the opposite variable and solve. And I'll ask somebody in a minute what's your x and y intercepts. All right, let's see what you got. What's my x and my y intercept? Going down the list here. Colin, here we go. What's my x and my y for this one?
Y is 8.
Yep.
And then x is 4.
Good job. All right, so they're both positive. Great. I'll graph them at the end here. Let's go to the last inequality. 2x plus 3y less than or equal to 12. Again, I'm just looking at my intercepts to see if they're going to be all positive, positive, and negative. That'll determine how I set up the graph. All right, so take this last one. Same thing that Colin just did for us. Find the x and the y intercept. Okay, what do you got? Boom. Caroline's not here. There we go. Sophia, what do you got for your x and y intercepts?
X equals 6 and y equals 4.
Yep. All right, everyone take a look. Does everyone see anything I'm going to graph is going to be positive? I got 0 and 0. I got 4 and 8, and I got 6 and 4. everything is positive, so we can just keep it to quadrant 1. All right, so you can go ahead, set up your graph in quadrant 1. First thing, let's go back. X greater than or equal to 0. What type of line have we always talked about for a couple weeks now? With X is all by itself. What type of line is that? X all by itself. Will, going back to you, what type of line is X all by itself?
Vertical.
Vertical, and it's going through 0. A vertical line going through 0. I think you guys graphed it already, didn't you? That's the y-axis. Here you go. X is greater than or equal to 0. My shading for that one, anything greater than 0. I'm going to recommend you guys don't shade, because here's what you would do for this one. Everything. It's the whole graph. Anything to the right is greater than 0. So I'm going to recommend you don't do that. All right, let's keep working here. What about this one here? Y greater than or equal to 0. What type of line is Y all by itself? So Dan, go ahead. What type of line is Y all by itself?
It's horizontal.
Horizontal, going through 0. You guys graphed this already. It's your x-axis right here. Y greater than or equal to 0. And I probably wouldn't shade that either, because here's what you're looking at right now. There's X is greater than 0. We haven't really narrowed anything down, have we, guys? We still got the whole darn graph as a possibility. All right, let's now narrow it down. Let's graph the other two right now. All right, let's get the real deal. All right, so 2x plus y less than or equal to 8. You guys, Colin gave me an x-intercept of 4. 1, 2, 3, 4. And a y-intercept of 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, a couple of you guys just pay attention here. You are connecting those lines, those points. You are connecting the points. Some of you guys are still in this habit. I'll make this line and I'll make, no! Those are 2 points that make your line here, solid line. All right, you don't make a horizontal and a vertical line out of that. You just connect the points. That's how this deal works. All right, let's talk shading. Should I shade to the right or to the left of that line? I don't know. Well, let's see what 0, 0 says. 2 times 0 plus 0 less than 8. Is 0 less than or equal to 8? Is 0 less than or equal to 8? Darn right it is. So 0, 0 worked. Going back to you guys at home, to the left or to the right should I shade then? If 0, 0 worked, to the left or to the right? Ooh. There we go. Ella, to the left or to the right? Not here. Try Nick. There you go, big dog. What do you got for me?
Shade to the left.
Shade to the left towards 0, 0. If you guys want to go ahead and do that, that's fine. All right. Again, I just want you guys to realize this isn't going to be my shaded region right here. It's going to be a little smaller than that when I graph the last line. All right. You're going to see me start waiting till the end to start shading. All right, so I don't have to shade. It doesn't look like 10 different colors are going on. All right, last line. X-intercept was 6. 1, 2, 3, 4, 5, 6. Y-intercept was 4. 1, 2, 3, 4. Connect them. Connect them. Don't draw a horizontal and vertical line through them. Connect them. Come on, get a straight edge. There you go. And I forgot the last one to label it, so I'll label this one. All right, beautiful lines, everybody, beautiful lines. Now test 0, 0 for this last inequality to see if I have to shade to the left or to the right of it. Let's see, 2 times 0 plus 3 times 0. Is that less than or equal to 12? 0 less than or equal to 12? Yes, sir. So 0, 0 worked once again. Left or right of that line? To the left or to the right should I shade? The line we just graphed, left or right? One, here you go. Liz, going back to you. Left or to the right if 0, 0 worked?
To the left.
To the left. Thanks, Liz. Good. So, guys, both lines are getting shaded to the left. Do you see the figure that is created from the shaded regions? Where the two shaded regions overlap, do you see the figure here that is created? Do you see the region that is created? Hopefully you guys see this one right here. If I shade both lines to the left, the shaded region would overlap right here. That's going to be probably the toughest part about these new problems, is finding that figure. All right, now I'm going to take the points from the figure. This is part B now. All right, part B asked me, find the value of the objective function at each corner of this shaded region. So you guys should have 4 points right now. 1 here, 2, 3 where the lines intersect, and 4 right here. Those are the 4 corners of that shaded region. You're just like we did in problem 1. We're going to plug them in to the objective function, see what gives us our max. Can somebody pick those points off for me? What are those 4 points? Top of the page. Bassett, good morning. What are the 4 points you got for me, Bassett?
4, 0.
4, 0, yep. 3, 2, yep.
0, 4.
0, 4, and that last one, can't forget about it.
0, 0.
0, 0, good job. Okay, those are the 4 corners of my shaded region. Now let's test it. Go back to the objective function up top. Plug in the x and y, and let's see what our z values are. All right, what do you got? What do you got for me here? There we go. Anna, here we go. Anna, 4, 0. What do you have for 4, 0?
8.
8, yep. 3, 2.
12.
8. 12. How about 0, 4?
12.
And 0, 0.
0.
Got it. Thanks, Anna. All right, so that was part B. And now take a look at the directions in part C. Use those values, determine the maximum value of the function and the values of x and y which make the maximum. All right, so first question, what is the maximum? Here we go. Colin, back to you. What's the maximum here?
Would it be on both 3, 2, and 0, 4?
Which gives you a max value. Yes, but
Oh.
those are the x and the y's. What's my max value from those?
12.
12. All right, so here's how we'll answer part C. The max equals 12, and it wants to know what x and y make it the max. So max equals 12 when x equals 3. X equals 3. and y equals 2. Also, you can see it gives us 12 in another case too. Also, when x equals 0 and x equals 4, or y equals 4. Okay, so part C said, hey, what's the max? And let me know the x and the y values that give you the max. And there was 2 different values that gave me 12. So that's what we're looking at here with these. Graph, shade, find the region, give me the corners, and plug them in. Anything you guys want to ask before we finish it on the third and final one? All right, let's see. Last one. All right, objective function. And I will give this to you for now. For now, I'll give it to you. All right, I'll give that to you for now. At the end of the unit, you guys will make up the objective function based on the problem. But for now, enjoy it. I'll give it to you. All right, before I set up my graph, let's take a look at my intercepts. I got between 1 and 5. They're both positive. I got y is greater than 2. That's positive. So the only thing I need your help with is, can you guys help me find the intercepts for this one here? X minus y is greater than or equal to 3. And then we'll set up our graph from there. So go ahead, x minus y greater than or equal to 3. What's my x-intercept? And my y-intercept. Okay, if you're ready, let me know here. Sophia, here you go. You got your x-intercept for this one?
Is it -3?
It is. Good job. And how about the y-intercept?
3.
Positive 3. Good. Now, hey, guys, do you see? Thanks, Sophia. Do you guys see I got a negative x-intercept? So I can't go and set my graph up like I did like the last one in the first quadrant because I have a negative x-intercept. So I at least need to make sure, I don't need to, I don't need to pull one of these 4 quadrants. I don't need all of that. I just need enough room on the x-axis to graph -3. All right, so however you want to set that up, just make sure you have enough room on the x-axis to graph -3. So I can, no, I want to do that. So I can do something like this. This is fine here. I got enough room to graph -3. There we go. All right, so let's go back up to the top. Let's graph these in order here. X is between 1 and 5. What type of line was X all by itself? Ooh, there we go, Anna. What type of line am I talking about? X all by itself.
A vertical line.
Vertical, good. So everyone at 1 and 5. Everyone at 1 and 5, draw yourself a vertical line at 1 and 5. So 1, 2, 3, 4, 5. X is in the middle. We're used to this. X is in the middle, so we would shade everything in between. If you guys want, go ahead. I know some of you guys are very, very neat, so I trust you. Some of you guys aren't neat, so I don't trust you. If you want to shade in between right now, go ahead. I'm just going to wait to the end. Next up, y greater than or equal to 2. Y greater than or equal to 2. What type of line? Isaiah, what type of line?
Horizontal.
Yep, going through 2, everybody. Right there. And while I'm here, I'll label that one. It's kind of hard to label the first one. All right, so I know I have to shade in between the vertical lines. Where's this one going to be? Y greater than or equal to 2, above or below? above or below for this one? Y greater than 2. You can plug 0 in and see if it works, or think about where all your Y's are greater than 2. What do we think, above or below for this one? Colin, back to you. Above or below?
What was the question again?
Y is greater than or equal to 2. That horizontal line. I'm looking for shading now. Should this be shaded above or below that line? Greater than 2.
Above.
Above. Good. So guys, see right now, here's where I'm at right now as far as a possible shaded region. This little rectangle right here. In between the verticals and above the horizontal. All right, let's make that smaller now. Let's go to our x minus y greater than or equal to negative 3. Negative 3 on the x. Positive 3 on the y. Graph your line in. Label while you're there. All right, to the right or to the left? Everyone go ahead if you haven't done so already. Test 0, 0 for me. Test 0, 0. 0 minus 0, is that greater than or equal to negative 3? I believe so. 0 is greater than or equal to negative 3. 0 is greater than negative 3. All right, guys, 0, 0 worked. Should I shade to the right or to the left of this? To the right or to the left if 0, 0 worked? Isaiah, back to you. 0, 0 worked. To the right or to the left?
To the left.
If I shade to the left though, I'm not gonna 0, 0 won't be a part of that shading. If I go to the
Oh, okay.
you see
so
what
you
I
want to shade to the right.
so, shade to the right.
Okay.
And then everyone go ahead. Can you find your region? Can you find the region where all 3 shaded regions would overlap? Find it for me. What figure does it make? In between the verticals, above the horizontal, and below the diagonal. Here you guys go. Should be right here. That's where all 3 would intersect. Perfect. That's where all 3 intersect. Give me the points off it now. All right, we got to take this next level now. Give me the points. I'm hoping you guys realize why it's so necessary to have a straight edge, because you're never going to know where some of these lines intersect if we don't make nice straight lines. All right, what are those 4 points that make up the region? What are the 4 corners? Come on now. Not back yet. There we go, Bassett. I can count on you here. Here we go. What are those points, Bassett? Hey, Bassett, be careful here. I don't want you to fall in a common trap that kids get in.
1, 2.
Okay, good job. Good job. Hey, just hold on 1 second, Bassett, because I know you know what the deal is here. Guys, a lot of kids, they start counting from one of the vertical lines. Please make sure you start counting from your origin. Start counting from the origin. A lot of kids, when they have vertical lines graphed, they'll start counting from one of the vertical lines. Good job, Bassett. 1, 2, keep rocking.
5, 2.
Yep.
Then 5, 8.
Good job. One more.
And then 1, 4.
Good job. Excellent. Count from the origin, guys. Count from the origin. And then go ahead, find your Z value, plug it into your objective. Find your Z value, and then I'll talk to somebody about what the max is here. All righty, what do you got for me? Caroline. We'll get to somebody. Maybe not. It's just not my day here with this. There we go. Nope, still not my day. The old Friday rest day. Kian, here we go, Kian. 1, 2, what you get for your Z value? Not there on that one, Kian. Left the meeting. Oh, look at that. Whew, all right, now the blood's rising a little bit. All right, Hunter, here we go. Somebody I can rely on. 1, 2, Hunter, what do you got?
For 1, 2, I have -1.
Yep, how about 5, 2?
5, 2, I have 11.
11, 5, 8,
5, 8 is -1.
and 1, 4.
1, 4 is -5.
Good job, thank you. All right, so those are my Z values. I'm not going to press my luck and call on anybody else here today. So same question for part C. What's the maximum? What's the maximum value and what X and Y gave it to you? Pretty easy here to find the max value. The max equals 11 for what XY pair? When X equals 5 and Y equals 2. All right, guys, questions? All right, you'll be practicing this on your own on Monday, and then we got one more day in the unit, and then we're going to be finished. All right, so you guys have a nice weekend. Enjoy it, behave, and be smart. I'll see some of you on Monday.
Have a good one.
See you later.